Hi and welcome back to our CS165. This is the second installation of our week 6 video, and this video is meant to help you with your lab exercise number 6. So it's already Friday and end ng week 6 at kaunti pa rin nagsasabit, so I guess medyo mahirap pag walang lab guide. So I am uploading this video para mas madali sa inyong masagutan yung lab exercise number 6. This figure is just to summarize that we have a known process that we introduced during our week 5. So that is by modeling, data characterization, creating an entity relationship diagram, and then depending on the entity relationship diagram, we can create individual schemas. And then if we can have several schemas already, then we can call for create table, etc. The problem with this design process is that this is highly dependent on the modeling part. And then it is also possible that the resulting table are not in good form. So may mga redundancies and may mga null values. So ang kailangan gawin if we have something like that in the collection of the schema is to perform normalization or gagawin natin in good form based from the definition of a normal form. So kapag ka naman we carefully design the entity relationship diagram, then there is no need for further normalization. Okay, so ito yung summary of all the topics that was introduced during the first part of the video. We defined what a good relational design is. Dapat walang redundancy and it will not incur records with null values. And whenever meron tayong not good relational design, what we need to do is to decompose the table, which is just a collection of attributes into two sets of attributes R1 and R2. And also note that not all possible decomposition of a table is good. May mga certain types of decomposition na tinatawag na lossy, and then meron namang mga lossless decomposition, which is the ideal case for us. So the idea of normalization theory can be rephrased by performing lossless decomposition doon sa initial table such that all the tables na resulting are in good form. So important na lossless, and important then that all the resulting tables are in good form. Next is whenever we characterize the data, in the real world, we have known constraints, and these can be formally defined as functional dependencies. These functional dependencies, you can also think of this as just some relationship between a set of attributes alpha and beta. And this functional dependency are in fact very related to the idea of superkeys. Yung constraint natin are not just one element or not just one relationship between the attributes, but sometimes it's a set. So it is in the set F. So if we have a set of functional dependencies F, we can also obtain a larger set, which is called the closure of F, that is the collection of all the functional dependencies that are obtained or logically implied from F. So in the previous lecture, we were introduced with the Armstrong axioms, and in fact, meron actually isang procedure that we could use to obtain all the functional dependencies in F plus given F. Okay, so one possible characteristic of a decomposition is that the decomposition is dependency preserving. So, yung functional dependency natin from the original table can be seen from the decomposed tables. And meron ding mga decomposition na not dependency preserving. And sometimes even if it is lossless, may mga decomposition din na dependency preserving at not dependency preserving. So, ang pinaka-important concept that was introduced in the previous lecture was the Boyce-Codd normal form. So, for the Boyce-Codd normal form, this is actually a normalization technique that we could use and also could serve as a condition to say that a particular table is in good form or not. So, you can think of this as a condition lang. And then, if hindi nag-satisfy yung condition na yun, there's a way how to convert one para maging in Boyce-Codd normal form. And in this lecture, we will show na may mga iba't iba pang types of normalization. And ito yung mga first normal form, second normal form, and so on. And may relationship si Boyce-Codd normal form in those ith normal form. So, in this presentation then, I will share yung mga different anomaly types. So, this will help you with the solution for your lab exercise number 6. Okay, so I summarized the normalization theory using this table. So I am summarizing the idea of normalization theory in just a single slide, and we will also know the different connection with different concepts that was introduced during the first part of the video. So let's start with the portion na we have a certain table. And this table can be some result from an ERD. So, yung table na yun, we don't know if it's good or not. So, what we need to do is to assess if it's good or not. And we can assess it by just checking if there will be anomalies, if we will perform some insertion, deletion, or update. And yung anomalies na yun can be redundancies in the contents of the data, and then some null values then. These tables can also be directly imported from an Excel sheet na ginagamit sa organization or form na ginagamit sa organization. So, hindi lang necessarily nanggaling sa ERD. Just like in your lab exercise, may nanggaling sa parang customer information parang form. So, first thing is to identify whether the table is in good form or not. And then, if it's in good form, then we're done. However, if it's not in good form, we need to decompose. So, in the decomposition, you just need to have some subset R sub 1 and subset of attributes R sub 2, and then you can use those set of attributes in the two different tables as a decomposition. And there are actually two types of decomposition. One is lossy and one is lossless. And to assess whether a decomposition is lossy or lossless, you need to have the set of attributes R sub 1 and R sub 2, and you also need the set of functional dependencies F. Okay. So, in fact, you also need to compute for all the functional dependencies that are part of the closure of F. So, the first method to identify whether a decomposition is lossy or lossless is by checking the inner join. So, if I perform an inner join between R1 and R2, and then yung resulting table is equivalent to R, then it's a lossless decomposition, which is ideal. The second method is by performing this. Okay, I need to compute the two, so check the common attributes of R1 and R2, and then I can get some set of attributes and then identify if these are part of the closure of F. So, at least one lang sa dalawang na-compute mo na functional dependencies ang dapat member ni F+. So, that's one way of showing that a particular decomposition is lossless. Again, the ideal case is that it should be a lossless decomposition. So, if we convert this idea into a set of conditions na sinasabi ni Boyce-Codd, ang idea niya ng good form ay yung conditions na to. So, the table which could come from the resulting table from an ERD or some Excel sheet table or form used by the organization is in Boyce-Codd normal form or in good form, sabi ni Boyce-Codd, if this is true. Okay? So, to say that this is true, we need to show that for all functional dependencies na parang alpha to beta, dapat either or at least one of the following holds. Either alpha to beta is trivial or equivalently beta is a subset equal dun sa alpha or alpha is a super key for R. Okay? So, kapag nag-disobey ka sa condition na to, the easiest way is just to show that there exists one or at least one na functional dependency alpha to beta na hindi nag hindi true for each of the conditions. So, ang equivalent statement niyan kapag ka no is that there exists some non-trivial alpha to beta and alpha is not a super key. So, if this is true, nag-violate si alpha to beta sa Boyce-Codd normal form, then by using alpha and beta, we can actually decompose the original R to some R sub 1 and R sub 2 such that yung R sub 1 niya is defined by alpha union beta and then yung attributes naman ni R2 ay defined by this expression. So, mas straightforward ngayon yung idea natin ng assessment whether it's in good normal form. If hindi, then there exists at least one na nag-violate dun sa rule. So, using that functional dependency, we can try to decompose. And then, ideally, you can have something like a final table na in Boyce-Codd normal form na. So, let's dig into the idea of functional dependency. This is very related to the idea of superkey. In fact, equivalent yung definition nila. And this is read as beta is functionally dependent on alpha. Note that alpha and beta are just set of attributes ng R. So basically, you're relating two sets of attributes from R. And one simple example na mas madaling magets is that if you have alpha as your primary key, and then if you have beta as the set of all attributes in the relation, then you can say that the set of relation is functionally dependent on the primary key, or the primary key is a super key for the set of all attributes of R. So, the functional dependency na alpha to beta is just some formalization kung ano man yung real-world constraints on attributes. For example, like, I have a student ID, dapat yung student ID ko is unique and it should identify me. Ganun din sa instructor, and so on. Okay? So, yung first na na-identify natin ng types ng functional dependencies are trivial versus non-trivial. It's a trivial functional dependency if beta is actually subset equal to alpha. Ang pinaka-trivial niyan is that beta is equal to alpha. So, alpha is dependent on alpha, parang ganun. And there are different types of non-trivial functional dependencies din. So, gagamitin natin yung mga several concepts na to define the first normal form, second normal form, and so on. So, ayan, makikita natin yan later on. And then, we also have what we call the closure of F. And note that F is just a set of alpha to betas. And hindi lang syempre isa yung functional dependency of a table. And you can, in fact, obtain more functional dependencies na logically implied by F and call it the closure of F. And that is by using the Armstrong axioms. And kung hindi mo gagamitin yung Armstrong axioms, you can actually exhaust and generate all functional dependencies that are part of F plus given F. Okay? So usually yung Armstrong axioms, they are used to verify if a certain alpha to beta is in F plus of F. So the idea of dependency preserving was already discussed in the first video. However, parang hindi ako masyadong satisfied dun sa explanation ko, so I will explain it again. Okay, so if you wanted to say that a particular table is in good form, imagine all the hassle of parang checking all possible functional dependencies in F+. And then show na hindi siya mag-violate. That is, at least one dito ay tama. So, medyo expensive yung pag-verify whether a particular table is in good form. So, what we need to do is to identify a decomposition such that kahit na anong decomposition mo, nag-hold pa rin yung functional dependency. So, there are several types of decomposition na kahit na lossless, ay hindi siya dependency preserving. So, magbibigay ako ng example in this slide. So, we are dealing with this particular instance R. And this is a relation na may attributes A, B, and C. And there is a set F, which is the set of the functional dependencies A to B, B to C. For simplification na lang muna. So, we have two decompositions here. The first one is dependency preserving. So, bakit siya naging dependency preserving? Because we can verify the A to B using R1, and we can verify the B to C using R2. So, ibig sabihin nito, parang nahati lang yung F mo into two tables, and you can still verify it using the decomposed version. This is a lossless joint decomposition. Yung proof nito is by augmenting rule. So, nasa previous slide yan. Okay? The second one is also a lossless joint decomposition, pero hindi siya dependency preserving. Bakit kaya? Because for this decomposition, una, we can verify A to B because we have a table with A and B. Pero we can't verify B to C kasi wala tayong B to C na table. What we have to do is to perform inner join of R1 and R2 before we can verify if B to C is true. Diba? Or if we can verify if B to C ay nagsasatisfy doon sa Boyce-Codd normal form conditions. Right. So there are different other types of normal forms. And the normal forms are just conditions to say na it is in good form. Kumbaga parang ganun. So, yung relationship ng 1NF, 2NF, 3NF, and so on ay coming from the relaxed version and nagiging very strict. So, if coming from the relaxed version, mag-start tayo sa 1NF. So, katulad nung idea about the Boyce-Codd normal form, papalitan lang natin siya ng condition. So, si 1NF, 2NF, and so on, ay may certain conditions lang na dapat mag-true. Otherwise, we need to do something. Right? So, but before we discuss about the different normal forms, ano nga ba yung mangyayari if we have anomalies in bad relational design? One question that was asked in your lab exercise was to identify the different types of anomalies. So, magbibigay ako nito ng example using our ins depth table. So, the first one is the insertion anomaly. If we will insert a record, it will cause an anomaly. Yun yung parang ibig niya sabihin. So, if I will insert department data science and may building na COD, for example, tapos may budget siya ng 200,000, this will cause some of the elements to be equal to null. Kasi, suppose, bagong department siya and wala pang instructors, of course, wala pa ako mailalagay na instructor sa part ng instructor dito sa buong table. So, magkakaroon siya ng null contents. The second type of insertion anomaly is when we have um, an insert of 100 different ComSci instructors. Suppose naging institute na tayo and then we have 100 instructors. The problem with this table is that we have 100 different ComSci Taylor 100,000. So may redundancy of information na. The second type of anomaly is what we call the update anomaly. For the update anomaly naman, whenever we update a record, nagkakaroon ng anomaly. So, an example is, what if we update the budget of the department? So, instead of 100,000, naging 200,000 na. What I need to do is to update all instances of this ComSci Taylor 100,000 to ComSci Taylor 200,000. So, kapag hindi natupad na lahat ng records ay mapalitan ko ng 200,000, it could lead to data inconsistency. So, that is an update anomaly. So, there is also an anomaly kapag nag-delete naman ako ng element. So, yung example ng deletion anomaly is this. So, suppose tatanggalin na natin si Wu sa record ng lahat ng instructors. Okay? So, pwedeng nag-end na yung contract niya or nag-retire na si Wu. So, since siya na lang yung mag-isa na nasa department na finance, if we delete the record of Wu, pa kahit yung department name, building, and budget ng finance, matatanggal din. So, parang as if nawala yung finance department pag tinanggal yung last na instructor na nasa table nito. So, that is a deletion anomaly. If I delete an element, tapos magtatanggal ako ng more information. The most relaxed definition of a good normal form is the first normal form. And dapat lang ay mag-obey siya ng 4 rules. And that 4 rules is you should only have one or single atomic value for each attribute. And then, the second rule is yung values na i-store mo in a column or an attribute should be of the same domain. So, same lang sila ng all valid values. And then number 3, all the columns in a table should have unique name. And then number 4, the order in which data is stored does not matter. So, the table is actually in first normal form. However, there are some tables na hindi naman naka-first normal form. And what we need to do is to convert it to a first normal form. So, the first condition dito ay hindi na satisfy, so hindi singular atomic. So, what if we have a composite attribute, like yung address niya, may certain subcategorization to like the city, society, etc. What you need to do is to flatten the headers such that unique pa rin yung unique pa rin yung names ng attributes, and then yung domain ng bawat column should be equivalent. So, you just need to flatten the headers if you have a composite attribute so that maging first normal form. And then for the second normal form, the idea is it should be in the first normal form plus some additional constraints. So, kapag hindi na satisfying second normal form, nandito lang siya sa part na to. If may extra condition, papasok na siya dito sa second normal form. And yung condition for the second normal form is that you should not have some functional dependency na tinatawag na partial dependency. If it's a partial dependency, then you can have a functional dependency na dependent sa portion ng primary key. So, for example, the building is functionally dependent on the department name. Actually, yung budget din, functionally dependent on the department name. But the department name is not the entire primary key for this table because the primary key is ID and department name. So, may partial dependency. What you need to do to address this concern is to remove the partial dependency by removing attribute building and budget, dito sa original table and then create another table na may department name. Okay, so sa first table mo, makikip mo yung department name. Sa second table mo, may department name ka pa rin and then you will have the building and budget. A stricter version of the second normal form is the third normal form. For the third normal form, it should be in the second normal form and it doesn't have transitive dependency. So ano naman yung transitive dependency? It is when we have something like this. Suppose we have this table and then we have the primary key in green rectangle. This is the functional dependency indicated by the arrow. So exam name is functionally dependent on the subject ID and the student ID. However, we have a functional dependency then on the parang exam name and the total number of parang points. So, in this case, for example, meron tayong particular student, tapos may first long exam, and then the first long exam ay 30 points. Yung lab exercise as exam name ay 10 points. So, merong functional dependency yung total marks depende sa exam name. Ang problem with this is, since we have this type of relationship na, we can also deduce na total marks has a functional dependency on the student ID and subject ID, so by transitivity. And if there exists this type of relationship, then we need to remove the exam name and total marks, yung second functionally dependent attributes, and then create an exam ID. So, ang mangyayari is, we will decompose this table into two tables na yung first table ay wala na yung exam name and total marks, pero we augmented an exam ID to specify yung pair ng exam name and total marks. So, na-decompose siya into two parts. That is how you will resolve yung mga in second normal form pero may transitive dependency. In Boyce-Codd normal form, it is required that that table is in the third normal form, and for each functional dependency na parang x to y or y functional dependent on x should be a super key. May missing part lang dyan. Pero dapat super key ang si x. So for example, we have this table. So yung key dito, yung primary key dito is the pair student ID and subject. And then the subject is usually based on the expertise of the professor. So the subject is functionally dependent on the professor. And since professor is not a super key, then this is not in Boyce-Codd normal form. And then how do we convert this type of table to Boyce-Codd normal form? Well, alam natin ito from the definition before. We need to decompose R into parts. And yung parts na to ay yung alpha to beta na to. So, in this case, we have alpha equal to professor and then beta equal to subject. And then the first table will be yung alpha union B, so professor and subject. And then the remaining part is the student ID and then subject. So here's another definition of the third normal form. And this is not defined using the second normal form and the first normal form. So, medyo magkalapit sila nung definition ng Boyce-Codd normal form. Yung first definition na napakita natin kasi was the Boyce-Codd normal form. So, highlighted in yellow yun. And then for the third normal form, may additional lang na item dito. So, at least one of the following holds. So, kahit na isa dito sa dalawa, or itong third lang yung nasatisfy niya, then it is in third normal form. So, kapag kayong third item lang, yung na-satisfy niya, it is in 3 NF. Pero pagka isa doon sa first two conditions, then it is in the yellow or in the Boyce-Codd normal form. So, bakit natin i-discuss yung third normal form kung may Boyce-Codd normal form na? Ang main purpose is to preserve dependency kasi hindi lahat ng Boyce-Codd normal form ay nagpe-preserve ng dependency. So, mahirap i-verify whether it's in good form. So, ang ginagawa is to relax yung condition na yun. So, actually, meron pang mga higher normal form. So, ito ay isang example ng fourth normal form. And yung fourth normal form is mas stricter than the Boyce-Codd normal form. So, yung condition ay, it should be in the Boyce-Codd normal form and it doesn't have multivalued dependency. So, this is another type of a functional dependency na tinatawag na multivalued dependency. So, ano ba yung definition ng multivalued dependency? A dependency A to B, or B is functionally dependent on A, and that particular functional dependency is multi-value dependency if for a single value of A, pwede kang magkaroon ng multiple values of B. Okay. Meron pang two other conditions, and yung conditions na yun ay dapat at least tatlo yung columns because we are relating 3 columns here. And then yung last condition ay if we have a relation with at least A and B and C as parts of the attribute, if there is a multivalued dependency between A and B, then B and C should be independent of each other. So, if satisfied yung definition ng multivalued dependency, then it is not in fourth normal form. However, of course, we can also have a way how to deal with Boyce-Codd normal form na hindi pa fourth normal form. So, for example, let's check this table. This table has a functional dependency from course to the S underscore ID. So, course is functionally dependent on the SID. And this is multivalued because for a single value of SID, pwedeng dalawa yung maging, or dalawa or more yung pwedeng maging value niya on the beta. And then, okay, tatlo lang yung attributes niya, so nag-satisfy tayo sa second condition. And then we also have two other columns na independent sa isa't isa. Okay? So, walang kinalaman yung course and yung hobby nila. We have a record with this case. Then, we actually need to store yung dalawang records na yun into 4 such that all possible pair of course and hobby are represented. So we can deal with multivalued dependency by highlighting yung dalawang independent attributes and then create 2 separate attributes. And then create 2 separate tables with SID and yung attribute na yun, and then SID and yung another attribute hobby. So, in summary, kapag carefully designed naman yung entity relationship diagram natin, there is no need to further normalize. However, hindi natin maiiwasan na may lapse yung pag-create natin ng entity relationship diagram. So, we need to further normalize yung mga resulting tables na to via normalization.